Alright, our lesson today is dividing fractions part 1. What we're just going to look at is using our basic division symbol that's aligned with the two dots, one above and one below it. Alright, so we're going to do a couple of examples. We're going to start off with a traditional division of a whole number divided by another whole number, just to get an idea of what's going on. So here we go. Example 1. If you have 12 coins and you want to evenly divide them between 4 people, how many coins does each person have? Now, a lot of you are going to jump immediately to the arithmetic. 12 divided by 4, and then of course that equals 3. Right? We know this. We're used to doing this. But what I'm going to do now is draw a picture of this so that we have a better understanding of how we do that when we're using fractions. Right? So we're going to use the same process on the next problem of making a picture to visualize what's happening. If I have 12 coins, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and I'm going to divide it evenly between 4 people. Right? So I want to see how many times 4 goes into it. So, starting with all 12 coins, I'm going to count 4 and stop. And then I'm going to count another 4 and stop. And lastly, I'm going to count the last 4 that we have and see how many groups of size 4 I ended up with. Well, here's my first group of 4, here's my second group of 4, and there's my third group of 4. So as we can see, if we take 12 coins and we count out 4, we can do that 1, 2, 3 times. Alright? So that's how we can visually represent the arithmetic problem, 12 divided by 4. Let's do that now again with example 2, except this time you see we're going to have fractions. If you have 6 boards and divide each board in half, meaning we're going to split it into 2 pieces, how many pieces do you now have? So let's draw out 6 boards. 1 board, 2 boards, 3 boards, 4 boards, 5 boards, and finally 6 boards. Sorry that the box boards aren't all the same size, but let's assume that we just have 6 boards generically. So what I'm going to do now is see how many times half of a board can go into it. So if I was doing the same thing I did in the last problem, where I count out 4 coins and then stop, now I'm going to count out half of a board and stop. And then I'm going to count my next half board and stop. And I'm going to keep doing that through all the boards. So essentially each board is being divided in half. Alright? So if each board got split in half, how many pieces do I now have is the question. Let's count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So essentially what we did is, we started with 6 boards, and now we ended up with 12 pieces. Right? Do you see what we ended up doing was we multiplied 6 by 2? And that's because each board was divided into 2 pieces. Right? 2 halves. Right, let's explore this a little bit more. Alright, so here's what's going on. Now, I know that a lot of you guys know what's going on. I'll just try to go real slowly for those of you guys who might be a little bit rusty on that. In the last problem, I had 6, and I divided that 6 in half. And what I ended up with was a new problem. I ended up with 6 times 2, which gave me 12. Well, where did that come from? Now, it turns out that what we do in math is, anytime you have fractions and you have division, we don't do the division. Right? So here is a division problem, and we're dividing by a half, and what we did is we translated it into a multiplication problem. And more to the point, we ended up multiplying by the reciprocal, which is the fancy way of saying the flip, of our original number. So instead of having 1 over 2, our half, we have 2 over 1. Right, so let's give you guys the rule. Here is the rule. anytime you are performing division with fractions, you change it to be multiplication by the reciprocal. Okay, so let's do a couple examples so you can feel a little bit more comfortable with this. Alright, so again, the rule was anytime you're performing division with fractions, you change the problem to be a multiplication by the reciprocal. Right? And that's what we did up here. We had 6 boards divided in half, which ended up becoming 6 times 2 over 1. Right, let's take a quick look at our examples. Alright, if you wanted to try these before I do them, I would recommend pausing the video now. I'm going to go ahead and go through it. So, practice and procedures. Our first problem is 8 divided by 2/3. So, is this a division problem? Yes. Is there a fraction? Yes. So instead of doing 8 divided by 2/3, I'm going to rewrite this problem as 8 times the reciprocal, which is just going to be the flip, 3 over 2. Alright, now, we just worked with multiplying fractions, which we know we're just going to multiply straight across and then reduce, or we can reduce it in the beginning if you choose to. I'm just going to multiply across for simplicity's sake in this problem. 8 times 3 is 24. 1 times 2 is 2. And now we have an even number on top and an even number on bottom, so I'm going to reduce my fraction to have 12 over 1, which is the same thing as 12. Let's recap that. We started with 8 divided by 2/3. This is a division problem and it has a fraction. I'm going to rewrite it as 8 times, change the division to multiplication, the reciprocal to make it 3/2. And then I just work out the problem as if we were doing multiplication. Alright, now let's look at the second one. So the second one, 15 over 2 divided by 3. Is this a division problem? Yes. Is there a fraction present? Yes. So what I'm going to do is rewrite this as a multiplication problem, except I'm going to change what I'm dividing by into its reciprocal. Again, it's flip. So if you remember, any whole number can be written as 3 over 1. And now we end up with 15 over 2 times the division changed to multiplication. And instead of 3 over 1, I end up with 1 over 3. Right, again, for simplicity's sake, I'm just going to multiply straight across like I do the fractions, and then I'll reduce it. So now we have 15 times 1 is 15, 2 times 3 is 6. I can reduce my fraction top and bottom by 3. 3 goes into 15 5 times, 3 goes into 6 twice. And I have an improper fraction, which in algebra is okay, but in our class, what we're going to do is write it as a mixed number. 2 goes into 5 2 times with 1 left over, so 5/2 is 2 1/2. Again, in an algebra class, improper fraction is normally what's going to be asked for. Currently, what we're doing, though, is writing it as a mixed number. Alright, let's do this third example. Again, if you want to pause it and go ahead and do it first and then check the work, do that now. Here we go. We have 6/5 divided by 12/25. Right, I made the numbers a little bit bigger this time because I want to practice what we learned with multiplication. Do we have fractions? Right, yeah, we have 2 of them. Is it a division problem? Yeah. Do we ever divide when we have fractions? No. So what we're going to do is rewrite this as the first thing stays the same, 6/5, and instead of division, it becomes multiplication, and it's multiplication of the reciprocal, meaning we're going to flip it, so that's 25 over 12. Alright, so now I'm going to have some bigger numbers, so what I might want to do is what we did with the multiplication, and I might want to rip apart my numbers first. 6 can be 2 times 3, 25 can be 5 times 5, and on the bottom my 12 could be 2 times 2 times 3, because that's 4 times 3 is 12. And I'm going to cancel out anything that matches on top and bottom. Here's a 5, here's a 5. Right? I have a 2 on top, a 2 on the bottom. I also have a 3 on top and a 3 on the bottom. So what do I have left on top? 5. And what do I have left on the bottom? 2. So 6/5 divided by 12 25ths became 6/5 times 25 over 12. I did my prime factorization and canceled out the pieces just like we did with the multiplication, and I'm left with 5 over 2, and just like the last problem, that's 2 halves. Okay, one more thing and then we're going to be done with this lesson. I want to do an actual application problem because you have a couple of them in the problem set that I'm giving you later. So application problems are important because it's really real world. So here's a real world example. I have 3/4 of an acre of land to build houses on. The minimum per house by law is 1/5 of an acre. How many 1/5 acre parcels can I get from my 3/4 of an acre? In other words, I have a chunk of land and I'm going to divide it into smaller pieces. How many different pieces do I get out of this? You see, it's a lot like that first example we had. So we're starting with 3/4, and then I'm going to divide it into equal parcels of 1/5 of an acre. Alright, so we have 3/4 divided by 1/5. Hey, do we have a division problem? Yes. Do I have fractions? Yes. So what I'm going to do is rewrite this as 3/4, because I always keep the first number, and then change the division to multiplication, and then I take the reciprocal, the flip, of 1/5, which is 5 over 1. I then do my multiplication straight across, and I end up with 15 over 4. Now, because this is a real world problem, and I'm asking how many parcels I end up with, I'm going to make this into a mixed number to answer the question. 4 goes into 15 3 times with 12. And then I have 3 left over. So 15 divided by 4 is 3 3/4. But it's 3 3/4 what? Well, we're asking about parcels. So I end up with 3 whole parcels and then 3/4 of a parcel left over.